This presentation video is over providing energy from fusion and was made by Max Wolff and Timothy Davis. First off, what is fusion? Fusion happens when two or more atoms collide at very high speeds and temperatures, causing the atoms to overcome the repulsive forces between each proton and fuse together. When fusion occurs, an amount of mass is lost in the process and released at very high speeds, creating vast amounts of energy. Because fusion reactions take an incredible amount of energy to start in the first place, many designs use deuterium and tritium, forms of hydrogen that have 1 and 2 neutrons respectively. These forms of hydrogen take relatively less energy to fuse than other atoms. There are several different designs for fusion reactors, but one of the most popular is the tokamak. Simply put, a tokamak uses large electromagnetic fields to control extremely hot plasma, giving deuterium and tritium atoms enough heat and energy to fuse, thereby releasing even more heat and energy. Nuclear fusion theoretically has several advantages. First, it can theoretically produce much greater energy than any other source of energy. Second, its helium products are quite safe when compared to possibly dangerous radioactive waste or greenhouse gases that negatively impact our environment. Last, its fuels of deuterium and tritium are quite abundant, as deuterium can be found in all amounts of water, and tritium can be synthesized from lithium and is reused in the fusion process.
So what are our current limitations on fusion? Well, current mass-produced materials are not able to reach the required thresholds for properties. One of the most critical issues is that while high-temperature materials such as refractory ceramics and refractory metals are used, they are more susceptible to crack generation and propagation due to their intrinsic stiffness and strength. Temperature is also a severe limitation, as the tokamak deals with extremely high temperature plasma. Here's where architecture materials come in, and here's why they work. Architecture materials, or archimets, are defined as materials whose properties are determined by their inner makeup, including composition and internal structure, not only at a micro level, but also at a larger length scales, up to the size of a sample or a structural member. High fracture toughness and high strength by the design of lightweight metallic architecture materials has been achieved. Controlling the architecture and advanced materials to tailor properties beyond structure and composition has provided a new paradigm into modern materials design. The current research that's being done on it is a threshold coverage above which a material can resist fracture due to impact, since there's high density plasmas and particles moving at high speeds. And in the case of the tokamak, which uses plasmas in order to continue the fusion, materials scientists are examining how plasmas react with the interior walls of the machine. There's also been assessment of the effect of composition and degree of relaxation on radiation response of amorphous metal alloys.